That's good.
All right, cool. So I'm David. I'm going to talk a bit about the Rust programming language. The symbol is for the Rust stations is the little crab. This is the happy crab. So Rust, if you are not aware, has been Stack Overflow's most loved programming language for the last 4 years, which isn't to say it's the best by any means, but for people who use it, they tend to enjoy it and want to keep using it. It's a fairly small community, but has some really great resources and is pretty popular. So I'm going to start with a little bit about, oh, Cat wants to join. Nice home distractions. So sorry about that. Rust is kind of a systems language, but it really kind of spreads between, where it runs like C, C++ speed. Is Zoom over the projector for everyone else too, or do you see the whole?
I think we see your whole slide. Yeah.
Okay, cool, thanks.
Yeah. There's a little bar from the keynote maybe we're seeing, but we have a good view of your slides.
All right, cool. So Rust is super fast. It's like C, C++ compiled. There's no runtime, so you're basically compiling down to a single binary that you can distribute. So that's how it can run in WebAssembly in the browser. It can also run on embedded devices. It can call C code. And it has a really interesting memory and mechanism and memory management. So we'll talk about that a little bit. There's no garbage collection. And this is straight from the Rust website, so it's not my words here. And it's also really reliable. It has some really awesome guarantees around memory safety and thread safety. And this is validated at compile time. So you have the ability to use what's called unsafe code, where you kind of go with like the C or C++ model where you manage the memory yourself, but by default, the compiler will keep track of all of that. So it's impossible to like double free a variable or do some of the classic errors that you'll see in these system languages. And I'll show a couple examples of what that can look like. And thirdly, it has really great ecosystem. There's Cargo for package management, Crates.io for hosting packages. It's kind of like works similar to NPM in JavaScript or PyPy, and it's really easy to use. There's auto formatter, really great compiler messages that we'll look at a couple examples. So it's really good, easy to get started, and actually really accessible compared to something like C, in my opinion. So it kind of gives you the best of both worlds. So you get that system level resource access without shooting off your own foot. And you also get really higher level abstractions. There's meta programming through macros. You have generic types, traits, which are basically interfaces, modules to structure packages and libraries in your code. And then you can do functional programming or object-oriented programming. It kind of gives you the flexibility to choose what you want. So in this example here, it's kind of just showing you a quick little functional bit, but declare a variable called squares, give a type hint that it's a vector, so you have that collection available. It's basically an array, and then you iterate through the numbers 0 to 10, call a function taking the value as a closure, multiplying it by itself, and then collecting that back up into the array. So you get this pretty slick ability to do like functional things in the language, the standard library. So one of the craziest things is the Rust ownership system. This cat is driving me nuts, I'm sorry. The concept of no garbage collection, but it's instead resource acquisition is initialization. So what this means is variables actually own their memory. So when you declare a variable in Rust, it actually, depending if the variable is going to live on the stack or the heap, it is tracked by that variable. So in this case, S1 is declaring a string on the heap called hello, and it owns that value. So when you say let S2 equal S1, you're not actually taking a reference to S1, you're copying the value into a new, like you're saying, I want to own this memory now. If you try to refer back to S1 again later, you can't because the compiler will tell you, well, that value's already been moved to a different variable. You're trying to borrow it again, but you don't own it anymore. So you're referencing something that you no longer have access to. So you can, if you use a mutable reference or borrow, which would be this little ampersand S1 example here, it would be fine. But in general, it's really strict about when you're using variables and how you manage them. So when S1 goes out of scope, that value is automatically dropped from the heap and the memory is managed for you. There's no garbage collection at all. So kind of another example of this, if you're taking, if you have a mutable variable and then you take a reference to that, so we say we have a string called name that's mutable, we get a nickname that's a piece of that string as a reference. If we then try to change the name variable, the value that's actually holding, the compiler will tell us that that's not allowed because someone else is still pointing to that value. So you changed it out from under them, which, in like Python, you can have two lists. One value is changing the list, and then the other reference is being changed automatically without you noticing. But Rust is really strict about not allowing that. So you'll hear people saying, "Oh, I've been fighting the borrow or the borrowing system because it can be really strict and frustrating." And again, you'll see the compiler here is like very detailed on exactly which line, what happened, and that it can be really helpful. And there's even like you can get more docs by calling the rustc explain with the exact number. So another pretty crazy thing in Rust is this macros concept. I guess it's crazy to me. If people use Lisp or other languages, it's metaprogramming is more standard. But for example, you can use this derive macro, which basically lets you add an implementation of the serialize function right on your structure here. So there's a library called serd that you just say derive the serialize method, and now if you call post passing in the structure, it will automatically use the implementation. So you can write the code in one place and then use it all over on other objects. Another very interesting idea is that there's actually no null references. Everything is either has a value or it can be none, but you have to deal with it. So there's this concept of options. So with options, you're basically saying if I have a value, it can either have something inside of it or it can be none. And I can use this match operator to look through each of the values, but the compiler again enforces that you do handle the default case and you can't just skip it. That is really good to have to think about the errors, but it can be a little tedious for prototyping something because you're forced to kind of deal with every case when maybe you don't want to. And there are some shortcuts you can do. There's in this the second example here, you're taking basically an option that's pointing to a string slice. So it either has some string inside of it or it's empty. And we call unwrap, which basically says, give me the value from the inside. So that's either going to end up being the string itself. So we say if that equals snake, do something. Or it's going to be none, in which case if you try to unwrap a none, it will panic and that will unwind the stack for you automatically and abort the program. So there's unwrap or else, and there's other things you can do, but it generally makes you, it doesn't allow you to keep going after you access no memory. It pretty much unwinds the stack and aborts the system. So it's kind of opinionated about what is allowed and how it works, but it enforces some of the safety that, again, something like C or C++ you wouldn't have. And I think what's kind of fun about it is that it does give you this access to the really low level memory management and super fast, but you can do stuff that's pretty high level, like making web requests really easily, serializing JSON, whatever. It's like pretty easily built in with the library. And that's kind of actually how I first learned Rust was after seeing Alex talk about her emoji index a few months ago. I did a quick one in Rust and that I just have a link here. It's on my GitHub, and it's there's libraries, and it's actually pretty easy to do. So it was pretty cool.
Oh my God, that's so cool. Thanks, David. Sorry.
Yeah, yeah. I was inspired to try it out. It's not nearly as neat, and it doesn't have like a website or anything. It's mostly just using the API and the type system and all that. But it was just a little project to learn it.
Nice.
Great. Questions?
I have a quick question. I know that Rust integrates well with C and C++, but how about all that, all the great Rust safety mechanisms that aren't in the, the C++ that you might integrate with? Like, how does Rust deal with that kind of interface?
Yeah, so whenever you call, so Rust makes it actually really easy. You just basically declare a macro on your function, and then that will invoke the C++ or C binary, I believe. I haven't actually done it, but it makes it really simple. But any external call is actually unsafe. So when you mark code as unsafe, the compiler won't verify that it's doing all of the memory safety guarantees. So you have to make any external call unsafe.
Could you show us the implementation of the emoji index a little bit? Be interesting to see what some of that real Rust code looks like.
I make this go down? Yeah. Let's see. Is this it? This stuff is go smaller. Okay. Yeah. Can you see this code?
No, we're just seeing the slides.
Oh, how do I change the screen?
I think if you stop sharing and then reshare again with just the window you want. Oh, okay, great. Now we see it.
Okay, cool. So yeah, so basically in Rust, when you create it's basically like cargo new, and it sets up the project for you. So you have this file. It's like, here are my dependencies. Here's my package, and then you could have a main where the entry point is to the application, and then lib, and you can declare modules if you need them. So this basically just enters it, gets the API token, creates the Slack client, which is the library I was using, that basically wraps up all of the web calls and returns values for you. So it's basically getting all the channels, and it's getting all the users, and then it's just kind of skip some bots and stuff, and it starts combining them into a list of results. So it ends up going into the library and kind of doing some of this code. So I guess when you see the double colons, I kind of like this about Rust, is that it's explicit in kind of weird ways, in that if it's like a member of something, it's just a dot or a method or a member, but if it's accessing the namespace or like the higher levels, it uses 2 colons.
Wow,
So,
it actually seems like pretty readable for someone who doesn't know any Rust.
yeah, it's really, I mean, compared to like looking at C or C++, it's like pretty easy to learn, and I thought it was quite easy. And you can build tests like right in, and it will run them for you.
Nice.
So yeah, it's like, and it has pretty cool stuff where you do like, you can do sort of like lambdas and functional stuff where it gives you iterators. You can enumerate them.
I wonder if it's faster, the emoji index in Rust too, because it was notoriously slow the way I implemented it. In JavaScript, if you were fetching too much data from Slack and then parsing it.
Yeah, I mean, my channel is like had like no messages, so it's hard for me to do any benchmarking or testing. But it would do like 200 at a time and just iterate through the channel history as long as you wanted.
Nice.
Yeah, so it does. It's kind of like this shortcuts. Instead of doing the mash, you can do if flat, and it will kind of shortcut that whole. You have to handle everything, so it just kind of. But again, you can have logical errors, even though you can't have like a null reference or unwrap something that is missing. But it okay is the concept of a good value, like a result, and then there's an error, which is an error that is handleable, like an IO error or something, and then there's the panics, which are, accessing something like null, which is something that aborts the entire operation of the program.
Cool. Neat to see all that real code. Nice to have the introduction, like these are the concepts, and then like here's a program. So thank you.
Yeah, happy to share. It was fun to learn. I'm still very new to it.